Okay, so now we've got a is 6, b is 14, let's go back and replace it into our r and f equations. So we have r is e to the 0.3t, so minus a plus b, so minus 6 plus 14 is 8 sine 0.1t plus b plus a, which is 20 cos 0.1t. And for f, we're going to have e to the 0.3t brackets, just need to see a little bit higher up, a cos plus b sine. So it's 6 cos 0.1t plus 14 sine 0.1t. Okay, now if we go back up, it says in which year the rabbit's predicted to die out. So when will rabbits be 0? So using this one, let's make 0 equals e to the 0.3t. So either e to the 0.3t is 0, which it can't be, or 8 sine 0.1t plus 20 cos 0.1t equals 0. So this equals 0 can't happen. They make this equal to 0. So 8 sine 0.1t will equal minus 20 cos 0.1t. We're going to get 8 tan 0.1t equals minus 20. So therefore we're going to get inverse tan, so 0.1t equals tan to the minus 1 of minus 20 over 8. Give me a second. Okay, so the first answer we get is 0.1t equals minus 1.19. Remember on a tan graph, the first answer you get is the one that's nearest. So that's 0. Our first answer was over here at minus 1.19. So the next answer we get, can't have negative time, it's going to be that one, and values are always pi apart. So we're going to add pi to that. 1.95. So therefore we get 0.1t equals 1.19 or 1.95. That was 1.95. So t on its own, times that by 10, is 19.5. I think t was in years, it started in 2000, so it'll be 2019, so mid-2019, 2020. Okay, next question. According to the model, how many foxes will be in the island when the rabbits die out? Let me just see from the mark scheme if they use 2019 or 2020. They used 2019 because it would be in that year, I suppose, rather than rounding up, it would be in the year 2019. So let's go back. So we now say that when, well, how many foxes, when t equals 19, we might use 19.5 and not, we'll try 19.5 I think first, because that's the value we got when they actually die out, and we'll substitute that into the Fox's equation. So f is going to be e to the 0.3 times 19.5 times 6 cos of 0.1t, which is 1.95, plus 14 sine of 1.95, and see what we get. Okay, I get 3744. And I think in the answers it was 3750, so I think they've been even more accurate with their... Yeah, they've got 3750. So I think if you plug in the exact value, which was a bit more accurate than the 1.95, you'll get 3750 for that answer. Okay, so it's right, it's just needs to be written in that form. So this is approximately 3750. But rather than getting 19.5, if you do minus 1.95 and you plus pi to make an exact answer, use that full answer, substitute it into the f value, you'll get your answer here. And finally, it was comment on the model, I think. Answers part 1 and part 2 comment on the model. So it's suggesting that there'll be 3,750 foxes when there are no more rabbits. Which is a large amount of foxes to sustain almost no rabbits at all. Let's just see what they've written in their conclusion. So, model predicts a large number of foxes on the island when the rabbits have died out, so it may not be sensible. Yeah, it's a ridiculous amount of foxes. They probably wouldn't survive because they won't eat each other. So, the last one, we would say... a very large amount of foxes when there are no rabbits left. So not sensible. Okay, that's question 7.